Okay, so what we're going to do is we're going to work through one project from the second portion of your problem set that asked if you were given four mutually exclusive projects, which one would you recommend? And what we did is we give you the information that's contained on the board as we can show you here. Alright, so what I've done is I've consolidated information. If I have a random set of cash flows, and the cash flows are described in the context of a normal distribution, they have these two parameters. They've got the mean and the standard deviation, or as we said, mu and sigma. Right? And so here's the values. Cash flows at time 0, 1, and 2. Mean cash flows or average cash flows of negative $50, positive $100, and another positive $100. And we have standard deviation of 5, 4, and 7. Of course, standard deviation has the same units as the mean. We have one additional kicker in here, and that's that we have a couple of correlations between the cash flows. Correlation between cash flows 0 and 1 of 0.3, and a correlation between cash flows 1 and 2 of 0.5. Okay, so before we get started, let's go ahead and put the problem into context. And the first thing you can see up here is that I've got variance, and that the variance is blank. So what we want to do is we want to solve for the variance, because we're going to need variance values as we solve for the mean and variance of the entire project. So of course, if you have a standard deviation of 5 squared, that's a variance of 25. If you have a standard deviation of 4 squared is 16. And then if you have a standard deviation of 7 squared is 49. And this is your variation. Alright, and then if you remember from class, we need to have our formulas for what the expectation is and what the variance is of net present value given a random set of cash flows. So for the expectation of net present value is equal to the sum of all the cash flows from time 0 equals to 1 to n, right? And we discount all the expected cash flows, CF I'll put as cash flows, at time t by our discount formula, 1 plus I raised to t. Alright, so that should look pretty straightforward. That's the same net present value formula. Let me close these parentheses. That's the same net present value formula that we've used in class to date for simple discounting, so it's not too much different. Where it does get a little different is when we start answering questions about variance. So the variance of our net present value is equal to the sum t equals to 0 to n of the variance of our cash flows, I'll put parentheses in here, time t, all over our discounting factor. The difference is we raise it to 2 times t, right? And that's our independent variance. And then remember that we said if there's a correlation, which in this case there is, right? If there's correlation in the cash flow, what we need to do is we need to add the correlation component to the variance, right? And so in this case, you recall from class, we add the correlation component, which is this big, scary looking equation of 2 sigma, right? Two sums. And this first sum is t equal to 0 and to n minus 1. And the second one is s is equal to t plus 1 all over n. Right? And then we have the actual factor. And the actual factor is pretty straightforward. In the denominator we have here 1 plus I, and that's raised to t plus s. And then in the numerator here we have our correlation coefficient between the two, right? Rho of t and s. And then we have the standard deviations of the two cash flows. So t, standard deviation of t, times the standard deviation of s. Alright, and so remember, when we were talking about this correlation component, we only have to evaluate this expression for cash flow pairs that have a correlation in between them, right? So in this case, we only have two. There's a correlation between 0 and 2, and there's a correlation between 0 and 1, right? This big summation notation, which seems pretty intimidating, actually is just making the statement of the combinations between 1 and 2, right? So it's saying there's a relationship between 0 and 1, 0 and 2, we add those together, right? And then this goes up 1, and then we have a relationship between 1 and 2, right? So those are all the combinations of cash flows. And so in this case, we only have two combinations. We only have a factor here, a correlation component there, and then a correlation component here. So we just need to evaluate and add those two components in. All right, so let's do the problem itself. First thing that we do is to find the expectation. All right, so our expectation of net present value is given by, in this case, we have at time 0 is negative 50 plus 100 divided by 1.1, of course raised to 1, plus 100 divided by 1.1 raised to 2. And those exponents, of course, come over here from the time section. And if you were to evaluate this, you'd see it should be a pretty straightforward calculation, and you'd come up with a positive net present value of $123.55. Okay, so the variance is a little trickier, right? We have a few more numbers that we have to plug in here. Net present value is equal to, and if we follow the same convention, right, we use the variance values. We use a different color here just to make it stand out a little better. Right, we use the variance values here. And so, of course, the first variance value is 25, and any number divided by, or any number raised to 0 is equal to 1. So the first variance value, just like the first cash flow value in expectation, is that same whole number. It's the same in the variance. So we have 25 plus 16 divided by 1.1 raised to 2. And why is it raised to 2, you might ask? Don't forget that over here we see that the exponent in the variance calculation is 2 times t. All right, and then so in kind, then we have 49 divided by 1.1 raised to 4. So also one thing you might ask, I jumped right in and told you 1.1. I didn't write it on this example, but the interest rate for this calculation, hopefully it's obvious by now, is 10%. We're assuming the MAR, or the weighted average cost of capital for this firm, is 10%. Okay, so this is the independent portion, and now we need to add the two correlation components, right? So because we have two of them, we have two factors to add. Just add them down here. All right, so plus a first correlation between cash flow 0 and 1 is 0.3. So 0.3 times the standard deviation of cash flow 0. Standard deviation, not variance, right? So 5 times 4, all divided by 1.1 raised to t plus s, so 0 plus 1, right? So raised to 1, and that's all multiplied by 2. All right, and then we add one more factor down here, plus 2 times the second correlation component is 0.5 times 4 times 7 divided by 1.1 raised to t plus s, or 3, right? Because cash flows 1 and 2 is equal to 3. All right, and if we were to evaluate each of these, you would see that the actual values would come up to, of course, 25. I'm going to change here. 25 plus 33.46 plus 10.9, and then over here I'll just put these values over here. This is the same thing as, oh, I'm sorry, go back here. This is actually 13.22 plus 33.4, and then over here this is 10.9, and this factor is 21. Make sure those don't look like inequalities. 21.03. Alright, and then you would see that the variance is equal to 103.63. And the standard deviation, of course, the square root of the variance, is equal to roughly 10.2%. Okay, and there you have it. So if you have any more questions about how to do these calculations, feel free to let me know in class. But please use this video as your guide to study the rest of the methods. Take care, and I'll see you in class tomorrow.